Solids, page 1. Um, we're introducing some new terms here, or maybe some old terms for you. If you have a three-dimensional solid, which is like a three-dimensional object, we talk about its faces, we talk about its edges, and we talk about its vertex or vertices. I'm going to show you what each one is. So the face is like a surface. So for example, this prism here, that's the top face, okay, and it has 6 faces or 6 surfaces. An edge is like one of these little blue lines here. That's an edge of three-dimensional solid. And a vertex is like one of these little points, okay, and the plural is vertices. There's 8 of these little points on this rectangular box here. And there are 12 edges on this rectangular box. So for these solids here, we're going to write down their name, and we're going to write down the number of faces, edges, and number of vertices. And then we're going to write down the number of faces and curved faces. Okay? So let's see. This first one here is a triangular prism. It is a three-dimensional pop out of a triangle object. So you make a triangle, and then you just kind of pop it out, and then it becomes a triangular prism. Now the next one here, B, is a pyramid. It's a rectangular based pyramid. Maybe it's square based, but we can't really see, right? And then C would be what they call a hemisphere, which I'm sure you know from your experience with the globe. Okay, half of a sphere. Okay, so let's write down the number of faces in a triangular prism. So let's see, we got 1, we got 2, we got the bottom, we got this side, and we got that side. So it looks like there's 4. Number of faces. What about for B? How many faces here? We got this side, we got that side, we got the front side, we got the back side, and we got the bottom. 5. 5. What about the hemisphere? How many faces does it have? Well, I guess it kind of has 2. It's got a curved one and it's got a flat one. How about edges? How many edges in each one of these now? Okay, so we just count the number of these lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like there's 9 there. For the pyramid, there's 1, 2, 3, 4, 5, 6, 7, 8. And for the hemisphere, it looks like there's just 1 round one. Okay, what about the number of vertices? Number of vertices. Number of vertices is like the number of points here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And here, there's no vertices at all, I don't think. Plane faces. Well, for like objects with flat sides, like A and B, the number of plane faces is the same as the number of faces. And they have 0 curved faces. Now for the hemisphere, the round part is a curved face, and the other side, the circle, the flat circle, is a plane face. So, okay, moving on. Draw prisms with these end faces. Now remember, it's like a prism is just, you just take like a 2-dimensional object, and then you just kind of pop it out. So it like a cookie cutter or something. Okay, we could just draw it right here if you want to. You could pop it out right there. You could pop them out. This is very easy for those of you who are in art class and for those of you who aren't. Okay. Page 2. Copy the cuboid shown in the diagram. In different sketches, Mark clearly these right angled triangles. Let's see, triangle ACD. ACD. Okay, that would be red. Triangle AGH. AGH. That's the pink one. Triangle HBA. HBA. Kind of like the pink one, just the opposite. And last of all, MCD, where M is the end midpoint of EH. EH is, okay, there's M. MCD. MCD. Okay, so we've marked 4 triangles there. Okay, all right. 3. The diagram shows a cuboid ABCDEFGH, where AD is 4, CD is 6, and CG equals 9, and they've already marked the lengths here for us. Find the length of DB. Let's see, DB. So DB is that length there. Can we figure that out from the 4, 6, and the 9? I think we can, because if we draw the bottom out like that, we will see that this one is 4 and this one is 6, and we want to know what this diagonal is here. But actually, we also know that this is 4 and this is 6 because it's a rectangle, right? So we can figure out that the orange line here is, we can figure it out with Pythagorean's theorem. So let's call this orange line x. X squared is equal to 4 squared plus 6 squared. So x squared is equal to 16 plus 36. So x squared is equal to 52, right? And so x is equal to the square root of 52. That is the answer to DB. Okay. What about ED? Can we figure out ED? ED would be that line right there. So ED. Now let's draw this triangle out. So we have E, D, and A. So we know that the height is 9, and we know that the width is 4. So this hypotenuse would just be equal to the square root of 4 squared plus 9 squared, which is equal to 16 plus 81, which is 90 something. 97. So it's the square root of 97. Okay, so that's ED. Okay, and what about DG? DG. DG. So DG is a triangle, and we're trying to find the diagonal here. The height is 9, and the bottom is 6. So this would just be equal to the square root of 36 plus 81, which is 36 plus 81, 117. So it's the square root of 117. DF. DF. So DF would be, it would be like a diagonal of a diagonal. So let's see, DF, we don't know. The height is 9. And you can see that the bottom of DF is actually that red line there, BD. And we know that BD is square root of 52. So x is equal to the square root of 81 plus 52. 81 plus 52. So it's the square root of 133. Right? That is DF. All right. Moving on to number 5. The diagram shows a cone with a base center O and radius of 4. The slant height of the cone is 9 centimeters. Find OV, the height of the cone. So let's see, this is not too hard of a problem. Basically, they're asking us to solve this triangle here. The hypotenuse is 9, the leg at the bottom is 4. They want to know this unknown leg here. Okay, and we could just use Pythagorean's theorem. X squared plus 4 squared equals 9 squared. X squared plus 16 equals 81. 81 minus 9, or 81 minus 16 is 65. So x is equal to the square root of 65. Okay? 7. The Great Pyramid of Giza has a square base. At the present time, the length of one side of the base is 230 and the height is 138. So let's draw that out. Great Pyramid of Giza, which is a square pyramid. It's got each side 230.4 and the height is 138.8. Calculate the length of the base diagonal. Okay, so that would be the red line there. So if we drew that out flat, it would this side would be 230.4 and this side would be 230.4, and we're looking for the length of the diagonal here. So we could use Pythagorean's theorem. So x equals the square root of 230.4 squared plus 230.4 squared. 230.4 squared is about 53,084. And we have two of those, so I multiply times 2. And I get a huge number, and I take the square root, and it gives me 325.8. 325.8. Okay, so that's the answer to A. Then it asks me, calculate the distance from the apex to the midpoint of a side of the base. So what they're asking for here is, they want to know from the top to this midpoint right there. And maybe the easiest way to do this would be to draw this triangle here. Okay, so then we would have, the height is 138.8. And the red dotted line here is half of 230.4. Half of 230.4 is 115.2. So now we just use Pythagorean's theorem again. It would be the square root of 115.2 squared plus 138.8 squared. Okay, that would be the pink length here. And then it says, calculate the length of one sloping edge of the pyramid. Okay, so now they want to know what this line here is. Okay, and so we could just draw that out flat again. And first I'm going to solve that here. So 115.2 squared. It's 13,271. And then 138.8 squared. It's 19,265. And then if I add those together, 13,271, and I take the square root, I get that the pink line is 180. Okay, and then so this one, this triangle here, the pink line is 180, so that's 180. And then this line here is half of 230.4. We already figured that out. It's 115.2. And then we just need to figure that out. So it would be the square root of 180 squared plus 115.2 squared. Okay? So we just repeatedly draw out these sloped triangles flat And then we use Pythagorean theorem to calculate that. Okay? And then we're on to page 3.